Well, good afternoon. This is a talk on Amazon SNS and SQS. I'm going to have a volunteer at the beginning. She's volunteered to pass out some candy. So anybody want some candy, raise your hand. She'll give it to you. Candy. So your applications look like this. Sometimes 404s, you get some delay in there. Ain't nobody got time for that, and they're waiting for it. And nobody wants an orangutan in pants waiting for application. Nor do you want a baboon on the keyboard to be waiting. And all of us think sometimes that our users are baboons at the keyboard, but sometimes it's our fault. So what are you going to do? I'm Paul Borlin. I'm a senior engineer at Compassion International. And I've also been an architect and senior engineer at various places like Philips and others. But I want to talk about Compassion real quick, because I have a passion for it. We release children from poverty in Jesus' name. And these kids like this, that they use the garbage dump for the playground, for their food, for their clothing, for their toys. He's got a toy in his hand that he just made by himself. And we give a better life by connecting sponsors like you guys to these children one-on-one. And then we have over 2 million children in the world that we've released from poverty and we support. And it's amazing to see it change lives from what they've done. We educate them, we give them food. We also give them clothing, and they sustain their life. So you can support, we're all over Europe, and your country's probably listed up here, so go support a child, and we can change the world together. So what are we talking about today? So we're going to talk about SNS and SQS, but before we do that, we need to talk about what are message brokers. We need to understand that before we can get into technical details. What are some of the advantages to using a message broker? What is Amazon SNS, and what is the Amazon SQS? Two separate things in Amazon. And then we're going to learn how we can communicate with that using Go. That's our ultimate goal. So what is a message broker? A message broker, this is a stockbroker. Here's the Wikipedia definition. I'm not going to read for it. You can go online and look at that. But essentially, it's a service that coordinates messages between other services. And they're good at it. It's analogous to the postal service. So if you have a postal service that routes your mail all over the place, you as a publisher of the message, you write an address on there, and you put it in a one designated spot. It gets routed to the other side, to another receptacle, which is kind of queues up the mail on the other side. All I care as a publisher that it gets to that mailbox. I don't care if my cousin or my uncle or anybody else gets it. I just want it to get to that box and get it taken out. So just like you have a place to publish your message, it gets routed in, it gets queued up on the other side. A message broker does the same thing with services. There's a publisher that publishes the message some ways, and it gets routed to a destination. Now, I don't actually have to know the directions to my uncle's house. The postal service does that for me. Same thing with a broker. So why use a broker? Seems like some middleware. Well, why not just do a REST call directly to it? Well, asynchronous communication is probably the best thing for it. So what would you rather do? Stand in that line up above? Or would you like to put a letter in the mail to deal with your business? Because you don't want to stand in that line. You can't do anything else while you're standing in line. Maybe you can play on your phone, but you're limited to what you can do. So the publisher doesn't have to be blocked when the message is published. You don't have to wait for some other service or some other entity to do something with a message. Also, back pressure can be regulated. So at certain times of the day, that line might get longer, shorter, and you don't have to have more tellers to deal with that. So let's talk about back pressure. So this is an example of back pressure in a restaurant. You have dishwashers that wash the dishes. At a lunch rush or a dinner rush, there can be different stacks, get bigger and smaller. And so if the waiter or waitress had to stop, wait there for the dishwasher to do the dishes in the order that they got there, the customers would be very happy, the waiter would be unhappy, and the dishwasher would probably be unhappy. So a real-world example with back pressure. When I worked at Philips Respironics, these CPAP devices are prescribed to people who have sleep apnea or they snore. And it gives pressure through a mask to help them breathe at night. So when a doctor prescribes this, they set the pressures, they set the flow, and they need to know it's working for a patient. So this device records that session while it's going. At the certain times of the day, that data is uploaded to our services, it gets parsed, it gets put into reporting, and then the doctors can see the reports, the patient's doing well. Well, we tried to randomize the upload of the data, but the problem with that, when you randomize it to help our services, patients would unplug their devices. They would do all kinds of wonky things with their devices, so the data was never getting to us. So a marketing person said, hey, when the blower, hit that blower off button, upload the data right then. Sounded great. We released it. What do you think the problem is with that? Everybody wakes up at the same time in the day, so our services got crushed. There was a problem with our services where we were trying to parse the data at the same time as we were pulling it off. So we re-architected, so we pulled off the data, put it on a message broker so that all our reporting and parsing can be done offline, and then we're starting getting data. So at the times where it's low in the trough, then the data can be processed, and our services, we didn't have to spin up more nodes. Our immediate reaction was to spin up more nodes. That didn't work. So most of the message broker was able to be that middleman for us. So now I'm going to give some highlights of message brokers really fast. I have another talk that I talk about these in details, but for this, I want to be able to get to the code. So high availability, multiple brokers or a broker has multiple nodes. Servers can be synchronized for those nodes. There's a guarantee of delivery. There's load balancing that occurs. And it can be alive when your back end is not there. Failover, when a node fails, others can take over. There's no data loss. Distribution, my favorite part of a message broker. Just like we talked about, I could just put the mail in one receptacle. The distribution, you can just publish to an exchange that gets distributed to the queues. This is the queues right there. So this is very analogous to me handing out the candy. So I gave it to one person. She distributed the candy. I didn't have to stop my talk to figure out who needed candy. Who got candy? A few people. So I didn't have to know who you were. I didn't have to stop my talk. Same thing with a service. The service doesn't have to stop what they're doing. So this is great for an event-driven or reactive design architecture. One important thing about a message broker, it does no work on the data, and it shouldn't. Just like you don't want your postal carrier open up your mail and dealing with your issues with your lawyer, you want it just to be delivered. Now, Amazon does break that with Lambda functions inside a queue. I would say use that as a last resort. Applications contact brokers. Brokers never contact applications. It's an important distinction. Brokers communicate in various ways. We'll be talking about HTTP because that's what Amazon uses. And additional features, we have retry logic, dead letter queues, time to live, auto delete, persistence and transient messages and queues. You have limits on your messages and queues, and different types of distribution. Various brokers out there, but we're talking about SQS and SNS. So when not to use a message broker? Well, I'd say if you have big messages, it's probably not a good thing. Now, how big is big? You'll have to check your throughput and figure it out, but I would say if your messages are getting up into 100K, think about what you're doing. Similar to REST services. If you need synchronous communication, don't use a message broker. I've seen people try it, it fails miserably. It's just like any other tool, if you don't need it, don't put it in just to play with it. Great usages for it. You offload work to be done later, like an example with my Philips Respironics. You need a quicker response to the user, which kind of ties into the first point. If you need to handle back pressure at various times a day, why spin up nodes and spin down nodes all day long? Maybe that'll cost you money. Just have a message broker queue that stuff up if it's not important for that time. And more than one receiver is the best part of it, I think. The service doesn't have to do any discovery of which other services need that message. All right, we'll slow down a little bit. We'll start talking about Amazon SNS. This is a simple notification service. You have a publisher that publishes a message to SNS, and it says which topic it wants to publish it to. So a topic is just a named space that in SNS. You say, I want to put it there. On the flip side, different things can subscribe to that topic. So whoever subscribed to that topic at the time gets that message as soon as you publish it on there. Now, it's very important that if there's no subscribers on an SNS topic, your message will go into space, gone forever. So that's an important key to that. You can also do message filtering as it comes through. SQS, a simple queuing service. Just that. It's a bunch of queues that you put messages in. You have a producer and you have a consumer to each of these queues. So here's a topic and queues tied together. This is a standard message broker setup. Amazon splits the two out, whereas most brokers kind of lump them together. So there's the SNS part with the topic and the SQS with the queues. You have a service that can publish to the topics, but the service can also publish to queues. But you have to know about each individual queue. It's nice to have just publish to the topic, and then you don't care which queues or what services are spinning up and spinning down. And then you have one-to-many services subscribed to a queue, each queue. So advantage of Amazon SNS and SQS over other brokers, HTTP is simple. That's the protocol it uses. We all know how to use HTTP. It's easy. The SDK that Amazon built for all their stuff is very, very well built, and it's easy to use. There's no need for a shutdown. Some other brokers, you have to make a connection and shut it down later. It's hosted for you. How nice is that? Potential disadvantages of Amazon SNS and SQS, there's polling. Because it's HTTP, you say, do you have a message? No. Do you have a message? No. Do you have a message? Yes. And it gives you a message. There's some ways to ease that, but we'll talk about that later. Cost. Maybe you have a lot of throughput. Maybe that's going to wreck your pocketbook. So maybe some other alternatives might be there. It may not be as fast as other brokers. There's various reasons for that. If you have questions about that afterwards, I can talk about that. Messages have a max life of 14 days. That seems like a long time, but if something goes on in production, you may not want that to start destroying your messages. Need advanced features in other brokers. So the other brokers have some more advanced. This is simple, both simple notification and simple queuing for those two. All right, enough of my talking in PowerPoint. Let's see something cool. All right, let's first go to Amazon, and I'll show you how you create a queue. Where did my thing go? I'll skip that. I'll come back to that if I got time. So I have an application that I built. Let's do it. What's going on? All right, we'll come back to it. So I have an application that I built that interacts with SQS and SNS. So I have various pieces to it. I have a way to list topics, and I have a way to queue topics. So listing topics, do a list topic, and we'll show you the code. List all the topics I have set up, and the queues. So in these windows here, I have one publisher, and I have 3 consumers. So I'm going to start my publisher. And I've told it which, I'm going to use a topic and which ARN to publish to. And I'm going to have a subscriber having 3 queues on this topic, go days 1, go days 2, and go days 3. So now as I publish a message, it goes out to Amazon SNS and gets distributed to this one that's listened to a queue. Now I have 2 other consumers. I can listen to the other 2 queues. There's number 2. That message was sitting there waiting for this one to wake up. Somebody else subscribed number 3. That's sitting there as well. Now if I type more messages, they're all going to get a copy. So my publisher I never had to redeploy it, reconfigure it, or figure out anything else. It just works because I'm publishing to a topic. Now, what do you think would happen if I connect all the same queue? One of them gets them, another one. It's sort of random. And this is due to the polling we do with the HTTP. Each of these, it's just about timing. Now, if I type fast, maybe you see some. So my command line application, I explained that. Every time I hit enter, it sends the message off. Now, if I go subscribe back to the other 2 queues, all those messages that I just typed are still sitting there queued up. Now, you might have noticed that some of these are not in order. So Amazon's standard queue is not first in, first out. It just, there's various explanations for that. Amazon has a great definition of why things are FIFO, aren't FIFO, but the simplest answer is because of the clustering that it does behind the scene. All right, I'm going to try one more time with Chrome. I don't know where Chrome went in my, it's right there. Where is that? That's a weird icon. All right, so if you go to Amazon, you can select up here, go to SNS, simple notification service, to simply get there. And this is your dashboard. You get there. You can go to topics, and you can create a topic. So I'm going to create a topic. I'm going to call it demo. As simple as that. Now I have a topic that other things can subscribe to. So let's go SQS. Let's create a queue. Same thing, create queue. I'm going to call it demo 1. Now here's your options. You have a standard queue or a first in, first out queue. And it does give a simple description here of your differences. One important thing is you cannot subscribe a FIFO queue to SNS. So you have to use a standard queue. There's lots of other options I'm skipping over, but this is a simple demonstration. So now I can take this queue, and I'm going to subscribe to that SNS. So I can say subscribe queue to SNS topic. Pick my topic, demo, and I subscribe. I can go back over to the SNS, and if I hit subscriptions, my topic or my subscription will be there. So I'm going to go to my topic, and I'm going to go into my demo topic. I'm going to publish a message. Say hello. So that's published to the SNS because the demo was subscribed. I'm going to look in the queue, and here's my message. I'm going to open up more detail, and here's my message here. Hello. Now, we've got a bunch of other extraneous metadata that was thrown into the message. You can change that by going to the subscription, and we can edit it, and we can tell it, I just want the, oh, this is the topic, my bad. I can edit this, and I can tell it, I'm doing the wrong spot. Why is that? Subscriptions. I'm clicking the wrong thing. Here we go. Enable raw message delivery. So that tells it, I just want the message directly from the service, whatever they published. So now if I were to publish a message to that, I will just get the message straight. All right, back to my queue, see what's going on. And here it is, the second try, just none of that metadata. So that some of that metadata you could still get off the headers or the attributes of the message in Go. So you might not want to have to wade through all that stuff. Maybe you just want your data. All right, let's jump to the Golang machine. So let's talk about how to set this up in Golang or in Go. So first thing you need to do with anything with Amazon's SDK, you need to get a session. So I'm going to get a session, go for skull, common. Now I created myself a common function so that I can use it all over this application. And so to build a session, we essentially get credentials. And my credentials are the region, the access key, and a secret key. Now there's various ways you can do credentials in Amazon. I chose the access key and secret key for this demonstration. So you put that in your configuration for Amazon, and you create a new session. Easy as that. Configuration, new session, we return our session. So back to our demo. So the next thing, when you want to work with SQS or SNS, you have to get an instance of that. So I'm going to get an instance of SNS. And my ultimate goal here is going to be to list all the topics in that. So we do SNS and new. And I'll give it a session. So now I have a new instance of SNS. I call it SVC because that's what Amazon uses in their documentation. So now we're list of topics. So list output. I'm going to ignore the error like a good developer. And SVC dot list topics. Now I can pass a filter into it, but I want all of them, so I'm going to pass nil. And then with my list output, I have the topics inside of there, and I can do a loop on that and print it out if I want to, like that. So this is a boilerplate, and actually was a good developer. Well, I actually created this before. So this is a full version with the error handling. So you get a session to go over this again. You get a new instance of SNS with that session. Then you have your operation that you do. You get an output, and you deal with your output. Now you'll start seeing a pattern within Amazon's SDK. You'll have an input to the operation. So you have an operation. You have an operation. You have an input for that operation. So list topics input, and you always have an operation output. List topics output. So same thing with the queues. I can do that. You get a session, do a new SQS instance. I can list my queues and deal with the output and go through all the queues. Publishing. Let's look at publishing. So my application, you saw it running. I had a couple of command line parameters. One was the whether I want to publish to a topic or a queue, and that's that keyword here. So the topic, I'm passing the function of send SNS. And then it's going to loop through the console, look for input. So the reader, when it reads a new line, it's going to then try to send that as a message. All right, so again, we create a new session, and we're passing it to our sender since our sender was SNS, or this is function here. So we get a new instance of it. Now our operation is publish. We have a publish input, and there'll be a publish output. So there's a pattern there go with Amazon. So the publish input essentially takes the message and the ARN where it wants to publish that message, so the topic ARN. So we publish that, and then we can deal with the output. I don't have the output here, but one interesting thing about the output is the message ID. So when you put a message on SNS or SQS, it'll give you a unique ID for that message for reference later. Similar, if I had chosen to publish to SQS, same thing. I have a session. I get a new instance of SQS. I have my send message operation, send message input, and there'll be a send message output. And similar to the SNS, we have a body of the message, and we have the URL to send to. All right, consumer, a little bit trickier, but it's easy. So in my command line, I just grab the ARN that I want to subscribe, the queue that I wanted to subscribe to. So I'm going to subscribe to it. I get a session, get a new instance SQS, and then I receive the messages. So we'll look at that looks like. So again, we have operation that we want to do, receive message, and receive messages input. The input you have attributes, and you might ask what's the difference between attribute names and message attribute names. This is simply the message. This is the attributes that Amazon puts on it, and this is the attributes that you put on the message when you publish it. You have the queue URL where you're going to publish it to. Maximum messages, so that with the polling, help with that polling. When you say, hey, do you have a message? No. Do you have a message? No. If it has up to the max number of messages, it will give that to you. So instead of polling for every message, it'll give you bulk amount of messages. Wait time seconds is handy as well. So instead of it immediately returning to you, you can say, hey, wait 3 seconds before you respond to me. So in that 3 seconds, if Amazon has a message for you, it'll give it to you. So it saves on the polling. That can be up to a maximum of 20 seconds. Visibility timeout. So whenever you get a message, Amazon puts that aside for you. And nobody else is still in the queue, but nobody else can grab it. This visibility timeout says that, hey, hold this message aside 20 seconds before you put it back in queue. Amazon won't wait for you forever. You have to acknowledge it. All right, so I receive a message. I get the output. There's messages on the output. And I'm going to get those messages. I'm going to iterate through those. As I'm iterating through this is how you respond to Amazon that you're done with that message. Unless you delete the message, it will put it back in queue for you. So again, we have a delete message operation, we have a delete message input, and there would be a delete message output. So the input is the queue URL, and there's a receipt handle. So on each message, this is different to the message ID. They will give you a receipt handle when it gives you the message. So it gives you that handle that you can use secretly and say, OK, delete this. So something else isn't going to delete your message for you. So that's essentially the cycle of consuming. And that's the end of my talk. Thank you very much for listening and working through my Chrome issues. I'll put the code up on Twitter later. And any questions?
Hi. I used SQS in the past, like 5 years ago or something, quite heavily. And back then, there was actually the problem that there was always a certain latency. It was always delayed when I pushed a message into the queue. It could take up to 50 milliseconds with an instance running in the same data center. And when I contacted the AWS support, they actually told me, like, yeah, that's basically by design. We guarantee that even if you send 1 million messages per second, it won't be more. But even if you send just a small amount of messages, you always have this delay. Did this get any better?
Not that I'm aware of. It has to do, the short answer, again, the technical document, the documentation has a technical answer for that, but it's the clustering. It figures out where in its big cluster of servers where it can put it. So that is why I mentioned it might be a little bit slower than something else you might want to use. Any other questions? All right, well, thank you very much.